Oh, yeah. Oh, yeah.
Good morning, everyone. A warm welcome to all of you for this year's Bappu Memorial Lecture, which will be given by Professor Cynthia Larive from University of California, Santa Cruz. And this Bappu Memorial Lecture we conduct, of course, in the memory of our founder, director, Professor M.K. Vainu. And the previous Vainu Memorial Lecture was given by Professor K.R. Srinivasan from New York University, and the one before that was delivered by Professor Roger Vainu. So in the memory of our founder, we also celebrate a special lecture known as the Founders' Day Lecture to commemorate his birth anniversary on 10th August of every year. So that is different from the Vainu Memorial Lecture here. And a week from now, we are going to celebrate the anniversary of the Foundation Day of Indian Institute of Science, Indian Institute of Astrophysics, and we would also have a Foundation Day lecture next week. And let me also, before I invite our director, Professor Subramanian, to introduce the speaker, let me also mention that this lecture is being streamed online on YouTube, on our YouTube channel, and this has been organized by the Scope Committee. So with that, let me invite Professor Annapurni to introduce the speaker.
Good morning, everyone, and welcome to the visiting team from the UCSC, and particularly to the Chancellor, Cynthia Larive. This particular talk will go to the field stations everywhere and the YouTube as well, because we, as I mentioned to you, we are a distributed community in India, so everybody could listen to and participate. That's what Bill was mentioning. And I'm happy to have Cynthia today as part of the Vainu Memorial Lecture. And she's 11th Chancellor of the University of California at Santa Cruz, and she has an institution known worldwide for its interdisciplinary approach to research for the public good. Just as a brief introduction to her, Cynthia is the first generation college graduate earning her Bachelor's of Science from South Dakota State University and her master's from Purdue University, both in chemistry. She earned her PhD in analytical chemistry from UC Riverside while raising daughters Erin and Megan with husband Jerry. So one of the women achievers and flag bearers. Larive has authored more than 155 research publications and has received funding to support her research from National Science Foundation, National Institute of Health, US Department of Agriculture, Environmental Protection Agency, and a range of foundations and corporate grant makers. She came to the UC Santa Cruz from UC Riverside, where she was provost and executive vice chancellor. As provost, she was responsible for the academic enterprise, managing large-scale initiatives as well as the academic operations of the Riverside campus. Over her career at UCR, she served in a variety of other leadership roles, including Vice Provost for Undergraduate Education, Divisional Dean of Physical Sciences and Mathematics, and Interim Dean of the College of Natural and Agricultural Sciences. She's a Fellow of the American Association for the Advancement of Science and the American Chemical Society, and has received campus and national awards for her teaching, research, and leadership. An accomplished bioanalytical chemist, Chancellor Larive is also focused on research, innovation, and development, and developing the next generation of entrepreneurs through the campus Center for Innovation and Entrepreneurial Development, CRED. There are a lot more laurels and things to talk about, so I would cut it short and let's hear from Cindy. Thanks, Cindy, for coming, and over to you.
Can you hear me? Well, it's such a pleasure to be here at the Indian Institute of Astrophysics and to see you all. Thank you very much for attending, and thanks to anybody watching it live stream or on the YouTube channel. As our director just told you, I'm a chemist by training, so I'm not trained as an astrophysicist or an astronomer. So if I make any mistakes, my colleague, Professor Skimmer, is charged with correcting me in real time so that nothing persists on the internet. But it is such a pleasure to be part of UC Santa Cruz. And I'm going to tell you a little bit about why astronomy and astrophysics is so important to UC Santa Cruz, but also to the University of California system. So first, though, I just wanted to tell you a little bit about our university. We strongly believe that we are the most beautiful campus in the world, and I invite all of you to come to visit, and then we can debate whether or not it's true. But we were founded in 1965. We're a relatively young university, and we are a member in that short time. We've become a recognized research powerhouse, especially in areas like astronomy and astrophysics. And because of our research achievements, we were invited to join the Association of American Universities. This is the top 65 research universities in North America. And we also have, at the same time, a distinction of serving students from backgrounds that have historically not been represented in higher education. So we're what's called a Hispanic serving institution. These are American universities that have at least 25% of their students identifying as being of a Hispanic or Latino heritage. We're also an Asian American, Native American, Pacific Islander serving institution. And so this intersection of extremely high research activity, but also serving a diverse community is unique in the United States. And this combination, though, of rigor and inclusive practices is something that distinguishes the work that's done at UC Santa Cruz. So on our founding, we had two founding values. They were sustainability and social justice. And both of those ideals remain as poignant today as they were in 1965. So the recognition of astronomy by the UC system is widely recognized. As you probably know, our university system has 10 campuses in California. One of those, University of California, San Francisco, is only for graduate and medical degrees. They do not have undergraduate campuses. But UC Santa Cruz is one of 10 other institutions, many of which also have astronomy and astrophysics programs. So the UC faculty across our campuses who work in the areas of astronomy and astrophysics constitute 30% of the National Academy of Sciences members in the United States. That's a very elite group, and it's a real point of pride for us. We also have UC faculty members in astronomy and astrophysics who have won the Nobel Prize in Physics, a National Medal of Science, and numerous faculty who've been nominated and achieved distinguished fellowships and other awards and recognitions. So we highlighted three there. One is Sandy Faber, who's a UC Santa Cruz faculty member and an extraordinary woman. And she received the National Medal of Science in 2011, and she's pictured here with President Obama at the White House. Her work has just been amazing to think about how galaxies form and evolve. And also she's made great contributions to the optical design of telescopes and other novel astronomical instruments. Sal Perlmutter, I can't say it, I'm sorry, Perlmutter at UC Berkeley also won the 2011 Nobel Prize in Physics to try to understand how the universe is expanding. And more recently, Andrea Getz, our colleague at UCLA, received the 2020 Nobel Prize in Physics. So it's really an esteemed group of colleagues. And we might predict that maybe in 30 years it will be Andy Schemer perhaps on this one. I hope so, Andy. So I wanted to talk a little bit about astronomy at both the UC at the system level, but then also at UC Santa Cruz, and to help you see sort of how we evolved. And I had the real pleasure this morning of getting an overview presentation from Anna Purdy and others in the astronomy and astrophysics department here. And I think our evolution is somewhat parallel. So I really could identify that. And this was the founding of the UC Observatories before they existed in the UC. And that's Lick Observatory. So Lick Observatory was constructed in the 1800s, over about 11 years, on a place called Mount Hamilton, which is in the mountains east of San Jose. At this time, San Jose was a small village. Now it is the Silicon Valley, but at that time there wasn't much there, but it was a really good site for an observatory. And the UC Regents assumed responsibility for the observatory in 1988, and then Lick became the world's first permanently occupied mountaintop observatory. At that time, in the UC system, there was a single campus. It was Berkeley. Oh, there we go. So, this is a picture of the Lick telescope from 1988. And as it was built, it was 36 inches. And at the time, that was the largest refracting telescope in the world. And it held that title for about a decade. And then in 1895, they received the Crossley telescope, which was a 36-inch reflecting telescope. I understand it had to come from England. So they really did receive it there in San Jose. It was one of the first large reflectors ever to be built. And it was used in the discovery of new moons of Jupiter that hadn't been identified previously, and also the discovery of Mayhall's object using this telescope. So what I understand is that at first they thought Mayhall's object was a nebula of some sort, but then as later observations revealed, it was really the collision of two galaxies. So this research about galaxies and how they evolve had its very early beginnings. And sometimes science is like that. We observe things, then it takes much longer for us to be able to understand what does it mean. And so in the early days of the Lick Observatory, all of the staff lived there at the observatory, both astronomers and those who helped to support the work. Today, we still have 27 people who reside at the observatory. They have little houses there that support them. It is, although it's nearby San Jose, it's only 57 miles from Santa Cruz. Getting up the mountain can take some time, and sometimes there are conditions when it's not even possible. So in California recently, we've been having large storms. You might have seen news reports about the terrible flooding that has happened. Well, of course, at the higher elevations, one receives snow instead of rain. And so this is a picture just showing the mountaintop, but the road to Lick has been closed a couple of times this winter for periods up to a week or more, so the people living there have no access to get up and down the mountain. It's okay?
The screen on the live stream, people are not changing, so maybe we have to.
I'm sorry.
Is it shared?
Yes, it's safe.
It's okay? All right, sorry about that. In 1966, with the founding of the UC Santa Cruz campus in 1965, in 1966, the headquarters for the UC Observatory was moved to Santa Cruz. This is very important for the evolution of our campus, because when you start a new campus, you don't usually start with a world-class research group. And so having UC Observatories headquartered at Santa Cruz allowed us to very rapidly develop a distinguished group of astronomers in astrophysics. And I think that legacy continues today. We have many of our astronomy or astrophysics faculty have joint appointments between the observatory and the campus. You saw the beautiful location and the snow in the prior picture, but in 2020, we had a terrible set of lightning-caused fires in a very dry period. And this is just some of the damage that happened on the mountain. And there were about 50 firefighters and 6 fire engines that somehow got up that mountain. I don't know how the fire trucks navigated that road. But they, with help from the superintendent of the site, managed to contain the fire so that very little damage was done to the site. So all of the domes and the telescopes were preserved. There were some previously unused buildings that were destroyed. A few of the houses were damaged, and we're working to repair that damage. But part of the success in preserving the mountain and the observatory was also the foresight of those who managed the observatory to control the vegetation that grows there. Because by doing vegetation control around the domes, it made it possible for them to prevent the encroachment of the fire in a way that would, if it had been well vegetated, wouldn't have been possible. I saw the picture from your observatory in the Himalayas. It looks like nature has given you this benefit. So we still use Lick Observatory today. It's used for a really robust public outreach program that I'll tell you a little bit about later in the presentation. But it's also really important as a test bed for new approaches and new equipment. And so being able to have a place locally where you can test new detectors or new pieces of equipment before they go to Keck or before we build them for TMT is really very important. It also is a really important site for educational and experiences for both undergraduate and graduate students. And if I remember right, that our graduate students in astronomy and astrophysics really start their education by spending a week or two on the mountain and learning about things hands-on. And then we think it's really an iconic and beautiful site, and we're so proud to have it as part of our campus. I know that many of you know all about the Keck Observatories in Mauna Kea, but I just wanted to mention them too, because that's how we got to be UC Observatories in the plural, right, by adding telescopes at Keck. And so Mauna Kea is an exquisite site for astronomy for many reasons. But having the site at Mauna Kea really started in 1997 with the first telescope, and then a second observatory was added. And we're all hopeful about the TMT, and I'll talk about that in a little bit. So the W.M. Keck Observatory is a joint project between the UC Observatories and Caltech in Pasadena, but also with NASA and other partners. Keck was designed by Jerry Nelson, who was a really important influence at UC Santa Cruz and in the UC Observatories, and it was funded by a foundation, the W.M. Keck Foundation. The telescope has a set of mirrors and 36 hexagonal segments that are assembled to make a 10 meters telescope. And that's important, as this is, you all probably know this better than me, and that you reach a limit at which you can't make a good mirror, right? Because of the mirror size would cause it to have errors, irregularities in the optical path. So this idea of making the hexagonal segments and putting them together to make a big mirror is really an interesting one. And I'm so excited to be able to go later this afternoon to see your facility for polishing mirror segments. And so it will be very interesting to me to see how that's done. So at one time, the Keck Observatory telescopes were the largest in the world. Now they're the third and fourth largest. The location of Mauna Kea is really ideal for these telescopes because the summit stands alone. It's from a volcano. And so there are no nearby mountains that can create thermal disturbances in the atmosphere. The seas around Hawaii are very stable thermally, and there are few cities nearby to contribute to light pollution in the night sky. Having been to Lick in the evening, I can really appreciate this because you look down on the city of San Jose and the surrounding Silicon Valley cities, and there's a lot of light that comes from them, whereas from the top of the mountains in Hawaii, it's very dark. And so there's good visibility here for a number of days of the year, so it's a really popular site for our astronomers. I thought this was very interesting because I'm interested in adaptive optics. Many of you probably are more familiar with it than I am. But this use of the laser guide star adaptive optics system on the Keck telescope was, I think, a very remarkable work. And this work led to the Nobel Prize winning work of Andrea Getz for identifying this black hole at the center of the Milky Way galaxy. The system works by using a laser to excite sodium atoms that are in the atmosphere to create a kind of artificial star. And then that can measure the atmospheric distortions in real time. And then the adaptive optics produces sharpened images of the celestial objects that are produced really anywhere in the sky. So it's a corrective strategy. And I know a number of people here at the IIA are interested in exoplanet research. We're very interested in that at Santa Cruz as well. And so in 2008, these are the first pictures of exoplanets from the Keck. Until that time, exoplanets had only been detected from space. Probably it was the Kepler mission, I suppose, but maybe others too. And this work was contributed to by Bruce McIntosh, who was elsewhere at the time, but has now moved to join us at Santa Cruz as the director of the UC Observatories. And so managing the UC Observatories has been really important for our university and our work at UC Santa Cruz, and has helped us attract world-class researchers and community members and partners like the IIA. So I'd like to switch gears a little bit and move from talking about the UC Observatories in general to talking about some of the great work that's happening at our campus at UC Santa Cruz. So our campus is home to a really dynamic group of exoplanet scientists and theorists, planet hunters, instrument developers, people with a variety of expertise and interests to discover, observe, and understand the planets that live beyond our solar systems. And so it's a real area of strength for our campus. And so, we know that experiments are very important, but theory is too. And so this illustration sort of shows what an exoplanet could look like given our currently understanding of the planet. So some ways of trying to really combine theory and experiment to help us understand exoplanets. This, I'm really embarrassed now to present this because this is the work of Professor Skimmer. But I think this is really important, and I wanted to highlight it because it's really some of the basis for the SCALES experiment and the detector that we're collaborating with IIA to develop. This is from the James Webb Space Telescope. The images that have been coming from the JWST are so inspiring and so exciting. I think it's captivated the world. And it's really a point of pride for us at UC Santa Cruz that so many of our scientists have been involved with the JWST from its, really before it was the JWST, from its earliest ideas of creating this telescope, and then also the detectors that go with it. And both Natalie Battaglia, who works in astrobiology and exoplanet discovery, and Andrew Schemer, who's working in detectors, other things, are leading whole sections of the JWST data analysis. And it's really wonderful. And in this figure from one of Professor Schemer's papers shows how an exoplanet is detected here, and using different bands of the infrared light, being able to sort of identify the spectra from the exoplanet. As a chemist, this is important to me because part of the interest of identifying exoplanets is to being able to measure some of the molecules that are part of their atmosphere. And it is this near-infrared radiation across different bands that allows us to begin the process of identifying things like carbon dioxide and carbon monoxide, other compounds that are in the atmospheres of these exoplanets, and to start to stitch together the chemistry that may be related to the evolution of the exoplanets, but also the possibility of finding life. I also wanted to mention this really nice collaboration that we have at UC Santa Cruz called OWL. It's a good name, you know, but it stands for Other Worlds Laboratory. So it's an initiative that builds on our historic success in the study of planets inside and outside the solar system. And so it supports planetary research, not just in astronomy and astrophysics, but earth and planetary science and other departments as well. And one of their main activities is a summer program that's held every year on the Santa Cruz campus from 1 to 3 weeks, in which people come from around the world to engage with one another and drive discussion that can help really push the whole field forward in a very collaborative and friendly way. So we've also worked to help this program be inclusive of scholars from backgrounds that are less represented in the field. And I'll talk some more about that equity and access idea a little later. So astrobiology is something that has evolved from the exoplanet research, but was, you know, I think the idea was there much earlier in time. The chemist Urey was trying to think about how did RNA or DNA might have been evolved chemically rather than biologically. Many of us, you know, look at the night sky and wonder, who else is out there? How did we get here? So those ideas of how does life emerge and what are the conditions necessary for life are really fundamental to the human mind and the human heart. So our astrobiology faculty and students are really trying to think about how life forms, identifying markers that life produces, and the spectroscopic signatures then of those markers. And also some even thinking about the chemistry, about how we might be able to get formation of RNA molecules, for example, in the laboratory. So there's a lot of unanswered questions about the complexity of life and how it exists in the universe, but it's a very interesting idea. Another area of strength for the university is adaptive optics. This is practiced now widely in astronomy, and we have a UC Center for Adaptive Optics. But I also wanted to mention this laboratory led by Phil Hintz, which is very focused on developing complex adaptive optics instruments for the world's largest telescopes. And so this is a place where the Adaptive Optics Laboratory can help to train students who can then apply this technology and innovate in the ways that it can be applied in other telescopes and observatories. So this is a nice picture we got from Bruce McIntosh that shows how the adaptive optics can work. So in the first picture there on the left, you can see that without the adaptive optics, you don't get much resolution. Things are just really a blur. It's sort of like seeing a car coming onto you in the fog, right? Everything is just a big blur. But with adaptive optics and the corrections that it can make, all of a sudden, what you are able to do is resolve those objects in the center identified by the square and actually see them as individual objects in the night sky. So I think it's beautiful technology, and I think it continues to evolve. And I was interested this morning to learn about some of the approaches being taken in the scales detection. So theoretical astrophysics is also a very important part of our campus, and we have had extraordinary theorists as part of our faculty. Now with the advance of supercomputing, the theoretical astrophysics can accomplish so much more and accomplish more quickly. So using supercomputers, our theorists are able to test complex theories of the universe. That's important often as a predictor too of how to design our experiments and how to think about the experiments that we should be doing to answer the profound questions about the nature of the matter that forms our universe, but also how the universe is changing over time. I wanted to talk a little bit about the 30-meter telescope. I know it's probably well known to all of you, and that we're so pleased to have India as an important partner to the 30-meter telescope. And so this has been now a 23-year process to really imagine the 30-meter telescope. Began with the University of California Observatories and Caltech thinking together about the design of a telescope to be the successor telescope to those at the Keck Observatory on Mauna Kea. And so the 30-meter telescope would have 9 times the collecting area of the Keck Observatory. And the mirror segments within the design to assemble the 30-meter telescope will be smaller than those at Keck, but creating a significantly larger unit. And I know that this is an area that the IIA is really helping to lead within the planning for the 30-meter telescope. This is going to be so important because the TMT will allow us to detect a wide range of wavelengths from the ultraviolet to the mid-infrared at much greater sensitivity, almost 2 orders of magnitude increase of sensitivity compared to the Keck telescopes. And the images are going to be sharper than those of the Hubble and 4 times sharper even than the JWST. So this will allow us to resolve, the resolution will allow us to resolve objects that now are not able to be resolved. The sensitivity will potentially allow us to see even further back in time. And so it's the highest priority, the TMT, of the decadal survey that was just completed within the United States. So I think the United States remains fully committed to the TMT, and we're eager to see it moving ahead. There has been some problems, and if we hadn't encountered protests and the delay, that this telescope would almost be ready to be completed from the original plan. But I think we've learned a lot collectively and individually about the way to think about the building of the telescopes in Hawaii. And I feel that the project is now on a much better trajectory. And so the protests really were met by the native Hawaiians who objected to the building of the observatory on Mauna Kea, which to them is sacred. And so that has caused a pause in the efforts to build the telescope, but it's also given us then some time and opportunity to more meaningfully connect with the Hawaiian people and to build trust with them and to move forward in more sensitive ways. And I really have to give my deep gratitude to UC Santa Barbara Chancellor Henry Yang, who has been so instrumental in this process of really listening to the Native Hawaiian representatives and helping to set up a kind of program to move the project ahead. So I'm just going to highlight a few elements of that program. The first and the most important, I think, was that Hawaii developed an 11-member Mauna Kea Stewardship and Oversight Authority. It goes by MKSOA. Before this, the management of the observatory was done off Hawaii. But by centering that in Hawaii, that's very important. And the committee that makes up the MKSOA has a significant representative from Native Hawaiians. And so involving them in the oversight is really important. In addition, there are local business and elected officials who are and experts in land management. So the UC spends a lot of money on observing time from Keck, right? So the observation time doesn't come from free. In the past, that money went to the University of Hawaii. Now, that money will go and be used by MKSOA, and they have some autonomy over how that money is spent. I think that really helps to empower them and to create this more equal relationship between the TMT board and the Hawaiian group. And in addition, TMT has been implementing a new approach to education and outreach in Hawaii for the last couple of years. It underscores our commitment to respectful and long-lasting relationships with the communities in Hawaii, and that we're there for the long term and we want to be partners. And so one example of that is this UC Observatories project, Akamai Hawaii Internship Program. The Akamai program is designed to help support the development of a technical workforce in Hawaii and encourage students from diverse backgrounds to seek careers in science, technology, engineering, and mathematics. And so that aspect of outreach is something that's really central to the work that we do at UC Santa Cruz. So one of the things that we're very interested in, as I mentioned earlier, is providing access to all peoples to science, to astronomy, to astrophysics, because we know that we need as many bright minds as possible to tackle the world's biggest problems. And if we leave some people out of that equation, that the world will be poorer because of it. So smart people are born everywhere, and we should try to support their engagement and their involvement in our science. This is a really beautiful picture. It's I attribute it to our professor Enrico Ruiz, who is a very prominent astronomer. And he was at a meeting, a conference in Copenhagen at the Niels Bohr Institute. And so on the left is a photograph from a conference in 1933 held in this room at the Institute. And you can see, I see one woman there in the front, but the rest of them they don't look very diverse. It was the time, right? But now this is the photograph of the attendees of the conference on the right. And you can see how much things have changed. I take great pleasure in that success, and I think that it is an appropriate thing for us to be thinking about. And it's so great to think about. Here you have a woman director of the IAA. Such a pleasure to have a chance, us two women, to come together to talk today. So diversifying the profession of astronomy and astrophysics is something that UC Santa Cruz has shown real leadership in that area. And so we're asking, though, the same question across our university. So how can we develop faculty hiring practices and leadership hiring practices that support inclusivity and equity? So we're also really lucky to benefit from a group of champions like Sandra Faber, who was the first woman on the staff of the Lick Observatory and has but continued to open doors for others. And so she created the Vera Rubin Presidential Chair for Diversity in Astronomy, and Enrico Ramirez Ruiz holds that chair and uses the fund to support diversity efforts in the astronomy department. And so some of those efforts are related to outreach. So Enrico founded this La Motte program. Enrico's from Mexico, and La Motte means the star in Mayan. And as I told you, we're a Hispanic serving institution. We have a large number of children who grow up to come to UC Santa Cruz, and they're the children of farm workers who work in the fields around California, many of them, to provide the food that we enjoy across the US. And so La Motte provides an intensive research instruction, provides internship opportunities, computational boot camp, counseling, and professional mentoring. And through this program, we've been able to actually diversify the graduate students across many of the graduate programs in the United States, including at UC Santa Cruz. So we think that's a really important way to think about our pipeline of talent. Our astronomy and astrophysics department is also very active in outreach. And so this is something we were discussing a little bit casually earlier, is how do you get people around you to understand astronomy and to appreciate it? So most children might lie on the ground and look up at the night sky and be captivated by the moon and by the stars. And recently we had the alignment of the planets. And those things are just inherently interesting. But to be able to engage community members who have not otherwise had access to astronomy, we think that's a real opportunity. And so for 4 decades, Lick Observatory has hosted the Music of the Spheres program, which is a musical concert, an astronomy talk by world-renowned scientists, the opportunity to view through the telescope, and that was really exciting. I got to do that myself. And then also through the nickel reflector telescope, and then have discussions with amateur astronomers. So the amateur astronomers from Silicon Valley and all around also come, and they set up their own telescopes and help to different ones focusing on different things. Of course, Saturn is a great popular one, but you can see whole families there, from little children to the grandmas. They're looking through the telescope. It's quite inspiring. We also hold at Lick a Spanish language event called Las Noches de Estrellas for local high school students and their families, to bring them to the top of the mountain, to look through the telescopes, to be able to speak with astronomers and hear the lectures in Spanish. So the children all have English, but their parents, many of them, only speak in their native language, which is Spanish. So that's very important, because we know that the success of our students who come to UC Santa Cruz and their ability to think about their careers and their opportunities also depends on helping to bring their parents along. And so the goal of this program is to help students from underrepresented backgrounds learn about opportunities in astronomy and in science and engineering more generally, and have the opportunity to use real equipment and imagine themselves as being scientists. Finally, we're really pleased that we just received a $5.5 million grant from the Gordon and Betty Moore Foundation to support an expansion of our education and outreach programs at Lick. It's called Scientific Teaching Through Astronomy Research, or STARS, and the program will increase the number and the diversity of students who are able to take a part in astronomy activities, both at the observatory at Mount Hamilton, but also at local Bay Area communities. And we have an Institute for Science and Engineer Educators. This is important because those teachers who teach our children can have a really important impact on their future. So I'd just like to thank you for your attention today. It's been really exciting for me to be able to share a little bit with you about the history of astronomy and astrophysics in the UC system and at UC Santa Cruz. So thank you very much.
Thank you, Chancellor Larive, for this for this wonderful tour into the Astronomy A&A program at UC Santa Cruz. So before we take up a few questions with your permission, we would like to request Professor Annapurni to present her with a memento of our appreciation.
Thank you, it's so beautiful.
And
Thank you. We also have a small present for you.
I think you take care of it.
So I should have thought to bring a photograph from our astronomers, but this is a picture of our campus. And so I hope that you'll enjoy it. Thank you. Thank you very much.
So shall we go for a few questions if there are any? Yeah. So please.
My name is Rameshwar Rao. I did my PhD at UCSC in 1974.
Wow.
So it's very nice to see you. Things have changed, happened, and progress. And I'm really happy to see some delegations of UCSC coming here.
We're so happy to meet you. Thank you so much for being with us today. Who was your PhD mentor?
My chancellor, that time chancellor when I was there was the Mackenzie. And I did my PhD with George Hervey.
Oh, yes.
I was there from 1969 to 74.
In the very early days.
The very early days. After we Crossley reflector would be shown, and that's 120 inch.
Yes.
And Keck was just nothing when I left.
Yes. Oh, how exciting.
So,
What a pleasure to meet you, sir.
Yeah, thank you. So we have UCSC product here.
One of the oldest alumni here.
58 and all years back.
Yes.
Perhaps if there are any comments or questions from our online audience? There is only one chat.
Saying that the slides are moving.
Yeah, if there are no more questions, then let us, there is one from the lady there.
Yes.
It's very pleasure to listen to your talk. Thank you very much. And so I have just one question. So recently using JWST, so in one of the exoplanets they detected sulfur dioxide
Yes.
for the first time.
Yes.
So as an expert in the molecules and the as a chemist, what do you think about it and how important it is?
Yes, very. So I'll repeat the question for those online. One of the recent JWST experiments detected sulfur dioxide in the atmosphere of an exoplanet for the first time. And so that's very interesting to me. It's not so surprising to me, actually, because we know that some planets might have sulfuric acid in their planetary environments. And so I think that the presence of sulfur dioxide, though, could be very interesting. And it's always fun to detect something new. One of my questions would be, could we also perhaps see sulfur trioxide in the future? Because sulfur trioxide, if you add water to it, you get sulfuric acid. And so it should be able to be measured distinctly from the sulfur dioxide. But so it might be something to look for, might be present in less amounts. So one of the challenges in these kinds of experiments is that when you have one molecule that's there in a large population, and another molecule that's either much less or appears temporarily, right, that it may be more difficult to detect, but it could be something to look for in the future. But the other thing that's interesting to me as a chemist is often we think about equilibrium processes, right? And so that we'd set up some chemical equilibrium, but in a planetary system, we take ours, right? The atmosphere is not static. And so you can have perhaps either evolution of the molecules present with sunlight, or if there is weather or atmospheric winds, would you expect to see a temporal difference in the molecules present and in their relative abundances? So many questions. Like most new discoveries lead to more questions, right? So I'm excited by that. Thank you for bringing it up.
So you talked about inclusivity and diversity within the organization. So even though the management wants to make the whole campus or whole hiring, whole admissions, etc., go understand everything. So how do you make everyone in the system be sensitive to this particular thing? So would you run any particular programs or any initiatives within so that everybody is aware of this, the approach when they do any activity? Whether it could be short term or long term.
Yeah. So the question was, how do you, if you want to pursue greater diversity and inclusion, how do you bring people along in doing that? I think that it's something that's very difficult to do from the top down. You can't order people to be inclusive. It's probably not an inclusivity best practice. But I think that what we have seen is that a great desire among our faculty to help to promote an inclusive environment on our campus, to think about inclusivity and diversity as important values. So that's a set of shared values. I will not say it's shared uniformly across the university. Universities are complex in places. But what we have done is to, both in many of our faculty searches, but also in the administrative searches that I lead for our leadership team, is to ask individuals to write an essay on their contributions to diversity, equity, and inclusion. You do not have to be a diverse person yourself to be able to foster diversity, equity, inclusion. And so that has been a way for us to get to know people and what their thoughts and values are. And we tend to look at that essay, and then for leadership positions, then we look at their letter of intent or their CV. But for faculty, there's also the research proposals, which are so important. So to be able to look at the diversity, equity, inclusion essay, the research proposals, before you think about who did this person get their PhD with, right? So us chemists, we're the worst, I will tell you. Everybody worries about your pedigree, right? I'm a really common dog. I didn't have a great pedigree. Somehow I survived and succeeded. But I think that there is that idea of focusing on the person, what they would bring to the university, both in their research and their teaching and their values. That's one way to start to build a more diverse and inclusive environment. And for the undergraduate admissions, I have my colleague here, Michelle, who heads the department that is our undergraduate admissions. We do something very similar. So we do what's called holistic admissions. And we look at the accomplishments of the students who graduating high school within the context of their high school. So if you're a student who went to a private school or a privileged high school in San Jose, you've had a lot of opportunities. If you're the child of a farm worker in Salinas, whose parents are working picking lettuce and strawberries, probably your opportunities have not been so great. So what are the accomplishments of the students within their opportunity? Because what we really want to do is to help students come to the university and accelerate their progress, accelerate what they're able to achieve. So in the US, we think about social mobility. So what it means is taking students from the poorest families and through their degree, equipping them to be at a higher income level, say 10 years after graduation. That benefits the student, but it brings up the whole family. So it is in this way that we feel that we're making a great contribution both to our graduates, but also to our country.
I don't see, yeah, Brahma.
Just following up on that question. So once the students have been selected, how do you carry out the mentorship within the university?
Yeah, so I will talk in a very abstract, and Professor Schemer could talk about astronomy in more detail. But so we try to build programs that help to support students, and those programs I would say are in 3 different areas. So one is that for our undergraduate students, we're built on the Oxford model of residential colleges. That's unusual in the United States, but it does help to give the students a smaller and more supportive community within the large university. And they take a common set of courses. But we have learning support services. So this is tutoring, what we call supplemental instruction, which is after the lecture, someone else who helps to interpret the lecture, answer the questions, help support the student. We've installed video capture technology in almost all of our classrooms. So for me, quantum mechanics was very hard, and I would go to class and I would feverishly write my notes. Maybe you've experienced it too, and then try to go back and think about what did it mean. So now we can capture the lecture, and the student can go back and watch it again, stop and say, I'm lost there, go back and watch it again. Those kinds of technologies can be helpful. We have tutoring and additional kinds of supports. And then the other way is the more personal interaction. So this happens in a variety of modalities. Our faculty are very dedicated and are very supportive of our students. About 60% of our undergraduates do faculty-mentored research. And so in the research group, you have with the faculty member, the graduate students, sometimes the postdocs, you make a kind of little family for the student. This is a really helpful way to be able to support students as undergraduates, and then through research to be able to apply the knowledge they're learning in the classroom to something real. We also have a group of resource centers that are based on reaching out to different kinds of communities. So we have a resource center that serves our African American students, the Hispanic Latino students, a women's center. We have also a research center for our LGBTQ+ students. And so that there is a community that exists outside of the academic community where students can also find allies and friends.
Yeah, okay, so I don't see any more hands, but I have a small question.
Yes.
So since you also mentioned the astrobiology group, and I think that has a lot of overlap with chemistry, so that's why I'm addressing this question to you. So we hear of carbon-based life forms, right? So what is your opinion about silicon-based life form? I mean, is that a thing or?
We don't yet know. There is a very famous Star Trek episode that we probably all have seen because that's the kind of people we are. But yeah, you know, so the idea of having the non-carbon-based life forms is interesting. In the deep sea, there are events in which the organisms don't get their food from traditional sources, but use molecules like H2S. Other kinds of molecules, so their whole metabolism is based on that. There's still carbon-based life forms, but there's probably not a reason to imagine that carbon is the only way to have a life form, but that life might look very different. And would we recognize it if we saw it, right? So that's an interesting idea, but thank you for the question.
Yeah. Okay, so if there are no more questions, let us once again thank Chancellor.